Hello, welcome to my video on finding limits graphically and numerically. This video will apply to both my Calculus AB course and my Calculus BC course, and it's basically the first lecture for limits. So let's go ahead and get started. So the first thing we want to look at is just the notation. So limit notation looks like this. I'll give you an example of it. So this here says the limit as x approaches 1 of x squared plus 2x minus 3 over x minus 1. And so what that means is we're trying to find the value of that expression, the fraction there, as x approaches the value of 1. So you can see actually at x equals 1, you would end up with a divide by 0 error. So that expression is not defined at x equals 1. However, we can still take the limit many times. Okay, so let's take a look at that. Okay, so first, let's, as I had said, this means what is the value of the expression approaching as the value of x approaches 1. All right, so let's take a look at a graphical approach to finding the limit. So what we can do to find a graphical approach is we'll actually graph that expression. Of course, we have to graph it as an actual function. So here's the graph of the function f of x equals x squared plus 2x minus 3 all over x minus 1. And you can see it basically looks like a line with an interruption right at x equals 1. Okay, so if you were asking what value is the function approaching as x approaches 1, you can just follow on the graph. You see right there where that little hole is in the graph, we find out that the y value would be 4. So the function's approaching 4 as x is approaching 1. Okay, so that's really what a graphical approach to finding a limit is. Okay, now let's go to another graph. Let's scroll down here a little bit. So if we come to this other graph here, notice another example. We have the graph of a function. I don't tell you specifically what the function is this time, but just in fact, here's the graph of the function. And this question here is asking, we'll say this function is called g of x. So let's write that in there. So this is g of x. And g of x is approaching, it's asking what is g of x approaching as x approaches 2. So right there you can see there's our answer, that g of x is approaching 2 as x is approaching 2. So we say that this is equal to 2, and that's our answer. Okay, so you can see this is actually really simple so far. It's really just what the value of the function should be, even if the value is undefined at that spot. So if we were just to smooth it out and ignore the problem, what is the value of the function at that place? Okay, so now let's take a look at some one-sided limits versus two-sided limits. So notice this notation is a little bit different. See that little negative sign right there? So that negative sign right there just means that we're taking the limit as x approaches 2 from the left. So that'd be like we're following down this graph, like we're a little guy standing here on the graph. So a little stick figure walking there. And it is walking towards x equals 2. Okay, and that's coming in from the left. Okay, this one right here, that little plus sign, it means approaching coming in from the right. So we'll do a little pink person coming in from that side. A little pink stick figure. So they're coming in from this side and they're asking what are they approaching. And you can see in this particular case that this function, this limit as we approach from the left, so the little green guy is approaching 2. And on the other side, coming in from the right, it's also approaching 2. So you can see they agree, which brings us to the definition of when a limit exists. Okay, so a limit exists, and it's a two-sided limit, if the limit from the left is equal to the limit from the right. Okay, and you can see that's what's happening in this case. So that's an example of a two-sided limit. Notice this up here in this spot, this is a two-sided limit because it doesn't have either a plus or minus above and to the right of that 2, where this is a left-hand limit, this is a right-hand limit. Okay, so let's take a look at another example. Scroll down for that a little bit. So going under the same idea, let's take a look at this problem here. So this is asking what's the limit as of this g of x, new function. And notice this function has like a jump discontinuity in it. So as we come in from the left, notice that this is equal to 2. It's approaching 2. And we come in from the right, the function's approaching 1. Okay, and so you can see that the left-hand limit and the right-hand limit do not agree, and therefore the limit does not exist. So we'll say that the limit, I don't know why I'm not writing here, the limit, it's weird, as x approaches 2 of g of x, we'll say it does not exist, D and E. Okay, and that's because the limit from the left does not equal the limit from the right. Okay, so next we'll take a look at another type of finding limits another type of way, and that would be by taking them numerically. Okay, I think that's up here on the top of the screen. So if we want to find the limit numerically, what we'll do is take a look at another function. Now, this is actually the first function we looked at. This is x squared plus 2x minus 3 over x minus 1. And remember, before we looked at the graph, and we saw that the graph was approaching, I believe, 4 as x approached 1. So let's take a look at a calculator here. So here's the TI-84. We can do this on the Inspire as well. Let me get this in the screen. So turn this thing on. And I don't know why we're not getting anything on the screen. There we go. Okay, and notice I'm going into my y equals, and I'm going to put in my function. Let's make sure to put the numerator in fractions. So this is x squared plus 2x. It's a little slower on this than it is on an actual calculator. Minus 3. Okay, so that's the numerator in parentheses, divided by the denominator in parentheses, and the denominator is x minus 1, so x minus 1, and we'll put that in there. And we could take a look at the graph. We saw the graph before. It just looks like a straight line, and actually notice that on the calculator you can't even tell that there's a hole at x equals 1. So right there at that spot, that should be our value. But we're wanting to look at this numerically. So what we do look at it numerically is we want to go into table set first of all. So second window, which is where your table set button is, and we want to put the independent variable on ask. So right there, we'll hit enter. Okay, now if we go second table, you'll see that we get a blank table. It's x and then y1. So now we can put in values for x, and it'll tell us what the y is. So like if x was 0, we put in a 0 in there. I don't know why that. I tried it from the keyboard. It didn't work. So we put in a 0, enter, and we get out a 3. Okay, we can put in a 1, and we get an error. Well, that's not unexpected because we'd be dividing by 0 if we put in a 1. So what we want to do is we want to kind of sneak in from the left and sneak in from the right, getting really close to 1 without actually getting to 1. So like, for example, 0.9 is close to 1 without being 1. So we can put that in. We get 3.9 out. We could go closer, 0.99. And we get 3.99 out. How about 0.999? Put that in. We get 3.99 out. Okay, again, the 1 was the error. Now let's come in from the right-hand side. That was coming in from the left. So if we come in from the right, we'd be like 1.1. That's pretty close, but not 1. Then we could put in another one. Get some more space here. Oh, okay, actually, it only fits so much on here. It doesn't keep giving them. So we could come back up to this. We can put in 1.01. That was not what I wanted. Go back to the graph here, or the table. Okay, so how about 1.02? 4.01. Then we get 4.01, and how about 1.001? And we get 4.001. Okay, so you can see that as you come in from the left and you come in from the right, the y value is getting closer and closer to 4. So the way we'd actually illustrate our answer on this, we'll get the calculator kind of out of the way here. So we'll make a table, and we're going to be saying x and f of x, where this would be our f of x there. And when we put x equals, when we put in x equals 0.9, we got out 3.9. And we did 0.99, we got 3.99, and 0.999 gave us 3.999. Okay, let's extend that. And just so we can show we're sneaking up on it, we're going to put in our 1, and that, of course, was our error. No answer there. But we could put in 1.001, 1.01, and 1.1, and show what each of those answers were. If you recall, that was 4.001, 4.01, and 4.1. And you can see that coming in from the left that way, coming in from the right that way, both values are approaching 1, so this limit is approaching, is approaching 4, so this limit is approaching 4. Okay, that's how we do a numerical limit. Okay, I hope that was helpful, and I'll be doing more of these videos. Give me some feedback to see if anything can help. Thank you so much for listening.